Hello everyone. So this will be a very important video. So you have two capacitor E1, C1 and C2. They are initially charged to X and Y volts, and you have to tell the steady state value at these capacitor after applying V volts across it. Okay. So I have already explained this concept in previous videos. Still, I thought I should bring one more video regarding it. Okay. The interviewer may not ask you directly this circuit, but this complete circuit will be used in many questions. Okay, so as you know, we can solve it by two method one would be superposition, by superposition theorem. Okay, so what we'll do first, we will see the effect of only x volt at C1 only. I'm solving it for C1 only. Okay, first we will see the effect of x, uh, then y, then v. So for only the effect of x, what we will do, we will short circuit this V volt and Y volt. Okay, so plus minus C1 into x and C2. See, I have taken this direction for C1. See, in this direction I will write the charge. Okay, I will write the charge on C1 in this direction. So for C1 only, what would be the charge for, because of x volt? So it would be C1V upon C1 plus C2. Now how did I write that? Now in the previous C1V, not C1V, it would be C1 x upon C1 plus C2. Now in the previous video I have already explained this formula. Still I will explain once more. See, how many charge is there before C1x? Okay, and after C1 plus C2 into V. So what would be the charge? V equals to C1x plus C1 plus C2, because at the steady state both of them will be having the same charge, the same voltage, not the same charge, the same voltage. Both of them will be having the same voltage. So initially this was the only storing element, so it had charge C1x, and after that it would be C1 plus C2 into V. So this will be the common voltage as steady state. See, many of them would think there should be minus x. I know there should be minus, but I have taken this direction. For me, this is the plus. Okay, so I am writing the charge in this direction, so it would be plus only. Okay, now we will see the effect of y. So how would the circuit look like? C1 no charge, C2 y charge, uh, y voltage, sorry. So it would charge the capacitor in this direction, plus minus in this direction, but I am writing it like this. I am taking plus from here. So what would be the voltage because of y? It would be C2y upon C1 plus C2, but minus sign, because it is charging in this direction and I am taking it to be in this direction. So this is the voltage because of y. And now the third one, plus minus V volt, C1 and C2. So at C1 what would be the voltage because of V? So it would be C2V upon C1 plus C2. Why? Because we know for capacitor Q equals to CV, so C is proportional to 1 by V. So the voltage is divided in inverse proportion. So for C1 it would be C2V upon C1 plus C2. So what is the total charge? Now applying the superposition theorem, total charge at C1, not the charge voltage. I many times say charge. See, so what would be C1x upon C1 plus C2 plus C2V upon C1 plus C2 minus C2y upon C1 plus C2. So this is one method. Okay, this is the final answer. Okay, see, in the circuits you won't have such complex configuration. In most of the circuit you will get C1 equals to C2 equals to C. Okay, in most of the circuits, so it will be easy. Now I will explain one more method, then it would become very easy for you. Okay, now the second method, charge conservation. So I will again draw the circuit. V volt C1 C2, it was storing X, it was storing Y. Now see, if this voltage source provide you delta V voltage, then how much will be stored at C1 and how much will be stored at C2? See, at C1, because of delta V, we will have C2 into delta V upon C1 plus C2. Do you agree with this point? And for C2, we will have C1 into delta V upon C1 plus C2. Why? Because I have already explained C is proportional to 1 by V. So in the inverse proportion, we have divided the voltage. So at C1, what will be the total voltage now? After steady state, after reaching the steady state, X plus C2 into delta V upon C1 plus C2. Okay, and at C2, it would be Y plus C1 delta V upon C1 plus C2. Now simply apply the KCL, sorry, KVL. So V is equals to X plus C2 delta V upon C1 plus C2 plus Y plus C1 delta V upon C1 plus C2. From here delta V comes out to be V minus X minus Y. So at C1, what would be the total charge? At C1, V C1, it would be X plus C2 upon C1 plus C2 into delta V. I am writing this one, X plus C2 upon C1 plus C2 into delta V. What is delta V? V minus X minus Y. And at C2, VC2, what would be VC2? It would be Y plus C1 upon C1 plus C2 into delta V. What is delta V? V minus X minus Y. So now this is an easier method. Now I will simply show how you should write the charge without applying these equation and everything. Okay, so I will again draw the circuit. Now we will be having this circuit, and we have the condition that we have charge X and Y. We have voltage stored X and Y already on the capacitor. Now we have applied V voltage across it. Now what will be the steady state voltage across the capacitor? So now what will we do? So for C1, VC1, first we will charge whatever the first we will write whatever the voltage it is having, X plus. Now we will see what is the total voltage in it at t equals to 0 only. V minus X minus Y. See, apply KVL. V minus X minus Y. Okay. Now V minus X minus Y. Now we will divide it in inverse proportion. So it will be C2 upon C1 plus C2. Now for VC2, Y plus V minus X minus Y into C1 upon C1 plus C2. That's how we should write it. Okay. See, this expression and this expression both are same. Okay, you may simplify this one. You may think these are different, but these are same. Okay, I have already checked. Simplify this and you will get this expression only. Okay, so that's how you should write. So I will be dealing with many circuits like this, these questions. So it would be used in so the same circuit will be used in those questions. So I have first I have made this video. Now I will be coming with these questions, and there are two more questions. Okay, so these are famous questions. Okay, thank you.